Hello, everyone. My name is Dr. Rahul Kushwah, and I'm the CEO and co-founder of Deep Spatial. Deep Spatial is a geospatial artificial intelligence company which is headquartered out of Canada and is trading on the stock markets in US and Canada. We have developed our proprietary geospatial AI technologies, which are all around operations, planning, and governance. We strongly believe in that the true value of technology is not something which is measured in terms of how much you sell, but it's about how you impact lives. Because the moment you impact one life, that transcends through generations, and you're talking about impacting the society as a whole. And that's where we take pride in saying that over 50% of our offerings are actually catered towards sustainable development. We have developed our proprietary geospatial artificial intelligence driven technologies which are being used to sustain development and to promote sustainable development in fields such as education and healthcare. So today I'll be talking about how at Deep Spatial, we have been able to make an impact in the education segment, particularly in a remote part of a northeastern state in India. The name of the state is Meghalaya. And while I do so, I will also be providing you an introduction to our proprietary platform that can be used all throughout the world to promote sustainable development in education. So the particular region of Meghalaya where we deployed our technology has suffered from low literacy rates, even though the government has spent a lot of funds to support several education initiatives. And this tends to be particularly visible in higher failure rates of students, especially at the primary and secondary levels. And here are some of the challenges that have been faced within this state. I mean, these include gaps in the education system or school system, accessibility to schools, lack of proper access to healthcare, the varying socioeconomic conditions. And so the outcome that the government was looking for was how can we drive improvement in literacy rates and how and where the funding should be allocated such that this goal of promoting literacy can be successfully achieved. And we are actually extremely proud of the fact that our work has made an impact in the lives of over 15,000 individuals in the state. And this includes students, teachers, staff, and other stakeholders. And at the same time, right now, as we speak, the state is looking at the implementation of our platform all throughout the state, which is likely to impact over 1 million lives. So overall, what is our solution? What is it that we are offering? Well, later on today, I'll give a brief overview by showcasing or showing our platform. But in a nutshell, if I was to describe what Deep Spatial is offering, we are offering a platform that takes a 360 degrees view on education along with literacy rates, and at the same time, it takes into account multiple different data layers. And this corresponds to things such as infrastructure, student amenities, socioeconomic status, access to healthcare, as well as other parameters that you traditionally do not associate with education. The more critical part is that we have been able to use advanced AI modeling to identify the most critical parameters that would drive the successful outcomes for these specific KPIs, such as literacy rates, such as where should the money be spent to improve literacy rates. Along with that, we are also offering a visible representation of how and where the budget is spent, along with the impact it's having. In parallel, the platform is also offering prescriptive insights that you can visualize to see how it's going to impact things such as literacy rates. Now, at the same time, one other point that we need to bring forward is that the part of the world that we are talking about, I mean, this is actually a remote part of a state which is in northeastern India. So one of the biggest limitation we had was the access to historical data. And that's where we use primary data collection, and we have developed our own proprietary data sets, which actually encompass over 243 variables that relate to school infrastructure and 312 variables that relate to demographics. And again, now this has become a part of our proprietary data set, and we are using it not only to improve our AI algorithms, but also to assist us in terms of taking the platform and our technology to other jurisdictions. In terms of the actual AI methodology, I'm not going to go into the detail, But again, you guys, please feel free to reach out. My email information was there on the first slide. But the point that I would like to emphasize is that we are effectively the first ones in the world that have successfully applied geospatial artificial intelligence techniques to primary and secondary schooling. And at the same time, while doing so, we have been successful at modeling literacy through our proprietary AI techniques as well as proprietary data sets. And this is what makes our platform extremely powerful, that not only we are offering a platform that gives insights and it's outcome oriented, but we are effectively the first ones that have successfully utilized geospatial artificial intelligence to model literacy at primary and secondary school levels. So for this particular setting, I mean, again, I'm not going into the specific details as there were a lot of findings, but again, please feel free to reach out to us and we'll give further details. But what I want to emphasize is that we were able to identify, for instance, that how the presence of boundary walls in the government schools was the single most important factor that played a role in literacy rates. At the same time, we did identify other factors such as number of qualified teachers, total number of teachers, school category, the student-teacher ratio. At the same time, the other thing that we were able to accomplish was that we were able to deploy geospatial analysis, and in 3D modeling, we were able to visualize the gaps in school locations, which highlighted the accessibility issues at primary, secondary, and higher secondary school levels. At the same time, when we presented these findings to the Ministry of Education in the state, the Education Department referred to our insights as being an eye-opener. And this is where they began speaking with us, and now we are working on it together towards deployment of our technology all throughout the state. What we are offering is a platform that offers a 360-degree view, which not only assists in identifying the current situation with the schools along with its visualization, but at the same time, it is assisting with identification, analysis, prediction, prescription of measures, things that can empower policy and decision makers to promote sustainable development in education. And doing so, while we are doing it as we speak, we are impacting lives. And now we know that the value that we are bringing to the field with our platform is going to impact generations. Now, before I go, what I'll also do is I'll actually go over the platform. I'll give some high-level overview of the actual platform. So this is our platform, and this first page is essentially summarizing the overall insights about the project. The study area here is West Garo Hills. It's a remote part of Meghalaya. And overall, our analysis on the platform included 121 government and government-aided schools. It encompassed over 12,000 students and a bit over 1,000 teachers. And at the same time, these schools had an average pass percentage of around 28%. I'm not going to be going over every single tab because again, that's going to take a lot of time, but there are a few areas that I would like to emphasize. The first one is the school information and analysis. So when you click on this tab, first and foremost, this will give you an overview of the school. So basically what I can do is I can actually, let's say I want to select the school here. I can look at the basic school information. So let's say I select this school. It's going to show me all the details such as classrooms, boards, playground, boundary walls, toilets, information regarding number of students, teachers, student-teacher ratio, so on and so forth. Along with that, I can also look at the school infrastructure or some specific schools, and I can actually see pictures of what it looks like. And soon we'll be able to see how after these insights have been turned into action, how that has impacted these different areas as well. But at the same time, for instance, when we go on to this page here on the right, it's giving me an overall performance insights based on the AI and geospatial AI modeling. And clearly the single most important factor turns out to be boundary walls, as having a boundary wall restricts the students within the school, which results in better attendance. The other important factors that were identified were, for instance, number of qualified and total teachers, school category, student to teacher ratio, enrollments, presence of playground, and so on and so forth. But clearly the most important factor was the presence of boundary walls. The other tab that I would like to emphasize and show is actually the gap analysis tab. So the tab allows you to see what blocks are being served effectively by schooling all throughout the state. So let's say I want to look at the primary school gaps. So I click on this and I can actually identify what the individual gaps look like. Similarly, I can look at upper primary schools, secondary schools, the gaps that are there when it comes to higher secondary schools. So overall, what the analysis showed was that schools which had a primary or upper primary till secondary schools were showing better performance, and so the failure percentages of students was less. And therefore, we were able to identify gaps where the government should be opening more primary to secondary or higher secondary level schools within this district. The other tab I would like to show here is the spending efficiency tab. I mean, we don't really have time to go over every single detail, but this calculates the feature importance of budget heads as it relates to the past percentage of students. For example, what we found here was that the immediate intervention was required in 8 schools, which had maximum budget per capita, but less pass percentage. And at the same time, we were able to identify the most important capital expenditure affecting school building. At the same time, the most important recurring expenditure affecting schools, and which included salaries paid to qualified teachers. But again, I mean, there's a lot of information which is on this tab. Again, if anyone is interested and looking at the platform with us, please feel free to reach out and we can share a session where we can go over this together. So overall, with our proprietary platform and our geospatial AI technologies, we were able to make an impact on the education segment in the lives of over 15,000 individuals. And now as the project is scaling up, we know that we'll be making an impact to the lives of millions of people. At the same time, we're working on similar projects in other parts of India, similar projects in Africa. And something that excites me personally, as well as the entire team at Deep Spatial, is how we are using the latest technology, how we are able to accomplish what has not been done before in the geospatial AI space. And in doing so, we are making a direct impact in the lives of people by impacting education. Thanks again for your time. I really appreciate it, and I look forward to hearing from all of you. In case you want to reach out, my email address is rahul@deepspatial.ai. That's RAHUL at deepspatial.ai. Thank you.